Okay, for me, it's just a couple minutes later. Hopefully for you, it's been a little while since you did logic, but maybe you're doing back-to-back, so whatever. But we are back with our next lecture in this logic chapter. So the next lecture is going to be on what we call truth values. Truth values. So last time when we were writing up our statements, we talked about how some are true and some are false. And what do we do when one is true or one is false? And when you write a disjunction or a conjunction, all of a sudden it just starts to look kind of ugly. So mathematically, that's the same way. Even the same it is with our grammar, it's the same way with mathematical statements. So we want to have truth values. We want to attach a true or a false. Okay, and again, I apologize that this is not really that much fun, but again, it's a necessity. We got to do it. So, okay, so I'll just write down what I just said there. So we need to be able to tell if, or not if, but what statements are true, which we will just give a capital T, and what are false, which luckily enough is just a capital F. Okay. All right, so I'm going to write down a couple more statements here, and this time, instead of just writing down the statements, after I write them down, we are then going to say whether they are true or false. Okay, so the first one is, fire is hot. Okay. Now, we were all taught from little kids, right, that the fire is hot, don't touch, right? So this is a true statement, or I guess I could have just used the T, okay, but this is true. Now another statement is 8 plus 4 equals 12. That is also a true statement, isn't it? But what about 5 times 2 equals 7? True statement? Nope, this guy is going to be a false statement, right? So it's still a statement, but this one is a false statement. And then one more, 10 minus 2 does not equal 3. Okay. Now, even though it's got that negation in there, what we have written on the board is still true, right? 10 minus 2 does not equal 3. So this is a true statement. So even though there's a negative in here, that doesn't affect whether it's true or false. All right. Okay, so next what we're going to do is we're going to look at truth tables. So as we start to do conjunctions and disjunctions and negations and all of that, keeping these, deciding whether things are true or false becomes more difficult. So let's look at a conjunction, so a truth table for a conjunction to start with. So this is the way that we're going to do this. We're really going to make a little table, a little chart here. So we're going to have P, Q, and then P and Q. So remember, conjunction is and. So what we need to do is we need to make all the possible operations of true and false here. So the way you do this is by saying true, true, false, false, and then in this next column you go true, false, true, false. And now each combination is created there. Two trues, true falses, true false, and false true. So all of the different combinations are there. Now remember, when we do a conjunction, we need for both things to happen at the same time. So both things, bringing things together. So if the first statement is true and the second statement is true, when we bring those two guys together, well, their conjunction will the first and second statement be true? And they will, won't they? The first two are true, then the conjunction will be true. Now, if the first statement is true, but the second statement is false, now remember, we need both of these things at the same time. So when we bring both of them together, one of them is false. When we conjoin them together, doesn't that kind of mean the whole thing is false? Okay, so if both things need to happen, but one of them doesn't, then the answer there is going to be false. Same thing goes with the other way around. If the first statement is false and the second statement is true, when we conjoin them together, unfortunately, we're going to stay false. And then finally, on the last example, if the whole thing is false, first statement is false, second statement is false, if we conjoin them together, then the whole thing is going to be false. Okay, so remember what I said last time about the conjunction is very inclusive. Guys, I have turkeys that are going to join us in a second, so I'm going to close the door here. Give me a moment. All right, the turkeys absolutely love it when I am trying to do a Zoom chat or something like this. Okay, we're still good with the light. Okay, so hopefully that will keep them quiet. Sorry about that. Okay, so remember, and is very inclusive, so everything needs to work in order for the whole thing to work. So the only one that's true is if the first two were originally true. Okay. Now, let's do another truth table, but this time let's do it for the disjunction. So again, we're going to start with the P and the Q, but this last column here is going to be the P or Q. So remember, this always goes true, true, false, false, and then true, false, true, false. Now, or is like one or the other, so we're kind of loosey-goosey here. One or the other will work. So if both of the statements are true, if we take one or the other, are we going to have something that's true? And we are. Now, if the first statement is true and we disjoint it with the second statement that's false, now remember, we have true or false. We only need one of these things to happen. It's one or the other. So is there any truth to it at all? There is, because the first one was true. Now, likewise, if the first statement is false and the second statement is true, we only need one or the other, and one of the statements is true, isn't it? So this one will also be true. Then, unfortunately, on the last one, though, everything was false to start with. So whether we put them together with the word or not, if they're both false, life is false, right? So this one is going to stay false. So notice again with the truth tables, conjunction is going to be a lot harder to get a true statement. Okay, the conjunction, the and, is very difficult. The or, the disjunction, is a lot easier to get a true statement. Okay, so we just need some ounce of truth in it somewhere. The statement will be true. Here, everything's got to be true in order for the statement to be true. Okay. I know it looks a little bit weird, right? But you got to get used to it because we're going to do a couple days worth of this stuff. So, okay, so another way that we will see this is not in the table, but written, and not with the statements, but written with the T and the F. So we might see something like this. So it says, find the truth value. I know this, at first you're like, this is dumb, why are we doing that? But again, this is all just trying to get us good on our logic, okay? So if we have not false, well, what would be another way to say not false? Wouldn't that be equal to true? what if we had true or true? Okay, so if one thing is true or the other thing is true, then together is it going to be true? And what if we had true and false? So remember, that word and is far more inclusive and far more special. So because there's some false to it, that means the whole thing is going to be false, right? Okay, so now let's do this in the real world a little bit. Okay, so let me give you some statements that actually are, in words here. So we're going to again find the truth value. So this first statement says, there are 4 days in a week, or this is English class. So do we see that there are two statements there combined with the word or? So all they're asking us to do is to find out in the real world whether or not these are true or false. So the first statement is there are 4 days in a week. That is not true, is it? So we're going to say false. The word or means that we're going to write this notation. Everybody agree? Okay. So F or, and then is this English class? Well, it does seem like we're doing some grammar, doesn't it? But it is not English class, so this other statement is also false. So this statement could be written as false or false. And if we combine two falses with the word or, that's going to leave us with a false statement. And look at that. Everything about that statement is false, isn't it? Okay, so does it make sense that we should get a false statement there? Okay, how about this one? 5 minus 8 equals 3. And 5 minus 0 equals 5. So now we've got two mathematical statements hooked together with the word and. So our job is to decide, are these true or false? Okay, so 5 minus 8 is equal to 3. Okay, almost true, but not quite, right? So this guy gives us a false. Then the and turns into that notation, yes. And now 5 minus 0 equals 5. Now that guy is true, isn't it? So we have a false and a true. But remember, when it's the word and, it means that both things need to happen. And are both things true? They're not. So that means that in the end, this is going to be a false. Okay? Both things need to happen at the same time. All right, let's see the next one. A square has 4 sides and birds have wings. Okay, so again, two statements combined with the word and. So look at them separately to start with. So a square has 4 sides. True? True. This always works easier in class when you guys are actually answering the question. So I apologize if it seems a little bit weird. Okay, so a square has 4 sides. That is true. And means that we're going to go with that notation. Birds have wings. Also true. So 2 truths with the word and is going to give us a true, right? And if you look at that statement, the whole thing is true, isn't it? There's nothing false about that. So that is most definitely true. Okay, one more here. So 3 plus 5 equals 35, or 6 minus 2 equals 4. Now this time we're using the word or. Okay, so remember what we need here is just one or the other. But let's look at them separately to start with. So is 3 plus 5 equal to 35? That's going to give us a false, isn't it? The or, remember that's going to be that notation. Is 6 minus 2 equal to 4? And that's going to be true. Okay? So the word or means we just need one of those to work in order for it to be true. And one of them does work, doesn't it? So even though that one's false, because that one's true, and they're combined with the word or, then we get a true statement. One or the other of those is true, and that is definitely true. Okay. Okay. So let's look at this. Another example, but in a little bit different form. So you're going to kind of notice here that all they're trying to do here is get you very used to using notation and the trues and the falses, all the notation in all sorts of different ways, mathematically, symbolically, in real world examples. So that's what we're doing here. So this is another one. This one is just more symbols here. This says if P is true and Q is false, find, and I'll get ready for it, not P or Q and not Q. Okay, so this is the ugliest one that we've seen to this point, but all I'm asking us to do is put in trues and falses, okay? So even though it looks incredibly ugly, we'll deal with it, okay? But that's kind of our next step to getting into the next section, which is truly, truly ugly. Okay, so first thing to do is anywhere where you see a P, you're gonna put a T, and anywhere where you see a Q, you're gonna put an F. So we could rewrite this as not T or F, and, almost put an A there, not F again. Okay, now, the idea is not to get this done all in one step. Okay, think of it more like a math problem. Let's do it piece at a time. So the easiest thing to do now would be to flip-flop these nots, wouldn't it? So what's a not true gonna be? So couldn't we write that as false? We'll leave this guy alone. And then a not false would be a true. Okay, now, we've got to think of order of operations. So if there are any parentheses in a problem, we want to do that operation first. So if we will have a false or a false, well, everything's false, isn't it? So isn't that going to leave us a false statement? But then we still have it conjoined with this true over here. Now, if the first one is false and the second one is true, if we need them both to work, we need one and the other, we need all of it, this is going to stay false, isn't it? Because the whole thing is not altogether true. So what we did was we started off with a bunch of notation, and even though we didn't know what the two statements were to start with, okay, we didn't know what P and Q were, by just using symbols, we were able to tell that whatever P and Q are, if we're looking for that statement, not P, hold on, I gotta go.